Here's a video on how to process the data from our lab where we were looking at the angular velocity of a spring. Okay, so remember in the lab, omega squared was supposed to equal k over m. All right, and we're trying to show that relationship does in fact hold true, or hopefully, or see if we at least come close to that. So I took some data from some of your class members and modified it slightly. And so you probably have similar kinds of data. So in part one of the lab, we were testing how the amplitude affected the period, all right? And you can see as the amplitude goes from 1 to 5, the period sort of fluctuates somewhere around 0.6, all right? So the formula for angular velocity is independent of the amplitude. So what we're hoping to show is that the amplitude really doesn't have much effect. So let's go ahead and talk about how to process this data. First of all, if you want to put a grid around all of this, you can go over to borders, highlight it all, put in the borders, and choose to put those in. If you wanted to, yeah, we can do other things, but that is good enough for now, okay? Now, we need to calculate the angular velocity column, right? We could do them all by hand, but you should recall that angular velocity is 2 times pi. I think I have to, in here, I think I have to do pi of something. Okay, I believe it's a function. Okay, divided by the period. So the period is right here. And let's see if that in fact works. Yes, so that does give me the number, and it suggests that I autofill all the way down. So let's just accept that. And you can see the angular velocity is around 10.5 most of the time. Now, we have way too many digits. Okay, so I'm going to decrease decimal places a bit. That's plenty of digits. Okay, so we have the angular velocity in radians per second is staying very constant, right? Now, when we work in physics, we should be using meters, not centimeters. So what I'm going to do in this row is I'm going to take the first column and divide by 100, and that is my answer in kilograms. And once again, it suggests that I autofill, so let's just accept that, right? So this is the number of meters that I've stretched, okay, relative to the centimeters. All right, so those are my amplitude values. Now in this column, I want the square of the angular velocity. So I simply have to take the column back here, click on it, C3. You could type in C3 or select it and square it. And those look about right because the number is a little bigger than 10. Oops, I could have taken the suggestion of autofill, but I forgot to. So I'm dragging the corner down and that fills it. And I'm going to want to decrease decimal places. Let's just go to 1 decimal place. All right. And those are my angular velocity values versus the amplitude. All right. Now, there's a reason that I kind of staggered the table the way I did. What I want to do is create a chart that is going to use these numbers right here. And it's much harder to do the series for a graph if the columns aren't next to each other. And I do want to put the what is on the x-axis first and the y-axis second. That's the easiest way to do it. So now I'm going to insert a chart. Oops, and let's see. There we go. Okay, so there's my chart. All right, now I'm going to want to do all the things that we did before. I don't want it to be a column chart. I want to go down through my options, and I'm going to want to scatter plot. Okay, so those are my points. All right, and then I'm going to want to look at the axes. And this is fortunate. Okay, so when I look at the x-axis, it already, it's going from 0.01 to 0.05. That's good. What I like is that the y-axis actually does start at 0. Okay, so let me look at this. The x-axis is that. Use column D as labels. No, we're not going to use column D as the labels. So let's customize now. Okay, chart style. I like everything about it so far. Chart axis and titles. Okay, so when I go there, chart title. Need to add one. Whoops, chart title. So the chart title should be square, you can write it out, maybe square of angular velocity versus amplitude. Remember, you'll probably want to stop this video multiple times along the way. So when I instruct how to fill in a column, pause the video, do it yourself with your data, and then follow along. So I have a title in, so make sure you do that with your own data, and then move along. Don't watch this video all the way through and then try to remember everything. Theme, we probably want to have this title. Let's make it bold, and let's center it. So I want that lined in the center. That looks better. Okay, that was the chart title. Now I can look at the axes, horizontal axis. Okay, so this was amplitude measured in meters. So I'll put that on the horizontal axis. It's already centered. It looks good. Okay, I'll do the vertical axis. Okay, and that's, I'll abbreviate square of velocity, VEL, I'll say, and I'll put some periods so you know those abbreviations. All right, and that is in radians per second squared. Okay, so there I have it. I have my y-axis. All right, and so everything looks good with the axes. Series. Let's see, so we're looking at data series 1. That's the only series here. Okay, so I definitely want to put in a trend line. And when I choose to put in a trend line, I can pick which kind of trend line. I'm going to pick a linear one. I can pick how dark it is, but then I go down here and I want the label. Let's just use the equation. All right, and let's show the r squared value. Okay, so I'll click that. I do want to show the r squared value. All right. So what we can see in this data is actually not very linear compared to what we've seen before. 0.055 is a very low linear correlation because the data is kind of going up and down. And it's because it is a fairly constant relationship. It's neither trending upward or downward. As the amplitude grows, the square of the angular velocity pretty much just stays the same. So it's not dependent upon the amplitude. So you have a very, very low linear correlation. If you look at the slope of this, okay, it's 74.3 times x, but look at these x values. Remember, they're in centimeters, all right? So if you wanted x to be 1, you would have stretched it a whole meter, all right? So there's a very low slope considering that this is measured in we're only going to stretch this by a couple of centimeters. So in stretching it a few centimeters, the trend line is, it's sloping upward a little bit, but that's just because of the limited data. It's not because there's truly an upward trend. It's more or less a constant trend, right? So there we have it. That's our data for this, and I think we're all ready to go. So I'm just going to move it over to the side so it's not on top of my table. And that is the data that I'll need for my report. Okay. I should probably call this sheet 1. This isn't going to show up in the report, but for your own sake, if you were keeping track of this, this was all about the angular velocity versus amplitude. Okay. Sheet 2, I'll click on that. Change the name of that a while. This is about the angular velocity versus the mass. Okay. Now, when you looked at let's go ahead and do these columns. Okay, so we can calculate the angular velocity from the period as we did before. We can take equals 2 times pi. Okay, like capital PI in this program, and you need to give it an argument because it's considered a function, even though it's just a number. So you could type in 3.14. That would be good enough. But if you want to use more digits of pi, you do the pi of, and you don't need to put any number in for the argument because it's just pi. All right, but that's the wacky, weird way that we put it in here. And then you divide that by the period. And then it's just to autofill. All right, and now I have numbers. Now you can see the angular velocity is definitely going down as the period goes up, all right, because they're inversely related. When there's more mass, we have a lower angular velocity. It's oscillating more slowly, okay? Angular velocity is about how fast it's cycling, and it's cycling more slowly when we have more mass. There's more mass to move. So I'm going to just truncate some of those digits. Now we need the mass in kilograms. All right, so we're going to take equals to get an equation. Click on A3. It was in grams, so we have to divide by 1,000 to get kilograms. Yes, we'll autofill. And we want these, since they're in kilograms, let's add a few decimal places. Actually, I'll go right to there. Okay, that corresponds to the nearest gram. So those are the masses in kilograms. Now remember that omega squared is supposed to be equal to K times 1 over m. All right. So in order to figure out, I want to look at the 1 over the mass relationship rather than the mass. And you know what? Let's just call that 1 over m. So I'm going to change this to 1 over m. Right. And there we go. Now all I have to do is say this equals 1 divided by previous answer. Okay, and so that's 20. Fill it in. Now notice that not all of them come out to be quite the same. So let's decrease decimals. Let's increase it a little bit. Okay, that looks pretty good. Maybe I'll give one more decimal place there. Okay, so that's 1 over the mass. All right. Now we need the square of the angular velocity. So this is just the square of that column. So I'll take that and square it. And we have a bunch of numbers with, whoops, I was supposed to take that suggestion and autofill, but I can drag down and do the same thing. All right, too many decimal places, so I'm going to decrease the decimal places down. And that looks pretty good. Okay. Oh, I can put a box around, you know, I can put grids in all of this and go ahead and do this. Okay, so now I'm ready to put in my table. All right, and once again, I want to use these last two columns. That's why I put them in this order. I want 1 over m to be on my horizontal axis, and I want omega squared to be on the vertical axis so that the slope should be the spring constant K. So let me go ahead and insert a chart now. All right, and we're going to follow the same procedure. Let's say I'm going to go up to the top. I don't want it to be a bar graph. Remember, this is sort of built more for business than for science. So I'm going to change it to a scatter plot. All right, and I believe everything is good there. Oh, let's not use column E as labels, so let's get rid of that. What happened there? Column E, let's put that back in because I liked it better before. So let's customize. Oh, when I didn't do that, I was trying to do each column separately, as opposed to linking the data together. All right. So when I look at this chart title and axis, oh, chart style, let's go there. I'm fine with everything about the style. Just work your way down. We need a title. Right now it's on vertical axis. Let's go back to chart title. It is square of angular velocity. Whoops, I spelled correctly. Velocity versus 1 over the mass, the reciprocal of the mass. Okay, so that's my relationship. I want to get my horizontal axis title. Whoops. Oh, and I probably want to center that. So let me go back to chart title. And for format, let's make it bold and center it. That looks better. Okay. Horizontal axis will be 1 divided by the mass. The units are 1 per kilogram. You could say kilograms to the -1 if you wish. And then we do the vertical. Vertical axis will be square. Oh, let's do that again. It just popped up as an option from the last chart. Okay, so those are my axes labels. All right, so I think I'm pretty good there. And when I go to series, I want a legend that I don't want error bars, by the way. I do want a trend line. Okay, so when I look at this, I want a trend line, and when I pick the trend line, show R squared. And this time we definitely want an equation. Okay. So you can see that this is fairly linear. We only have 4 data points here, so it's hard to see. The linear correlation may not be so high, and because the way I adjusted these points slightly, but there seems to be a little bit of an up and down. But in general, it's not just sort of a random scattering. We definitely have a trend that follows this line that I have here, and it's a pretty linear trend, which is indicative that the square of the angular velocity is in fact I should say, related to 1 over the mass. All right, there's a reasonably good correlation between those for this data. Not quite as good as our linear stretching for springs, but it's pretty good. Okay, so the formula that we use, that omega equals the square root of k over m, seems to be a pretty good one based on this data. Now, one thing that we're going to talk about in our analysis, we know how much the spring stretched when we added 100 grams. We can use that to determine the constant K, the spring constant, all right? And that should come out to be fairly close to 12.5, but I'll talk about that in the next video. Oh, you probably want to move this. Whoops, let's move this over. You can just left click on it and then slide it or put it under your data, maybe put it there so that it's not in the way of the chart of your numbers. Okay, so I can put it to the side or down below, right? So that's how far you should get in your homework. You should have your tables filled out and your graphs made, and then we'll come back at the beginning of next week and do a quick report about our 2 graphs and make sure we draw the right conclusions. Okay, enjoy the weekend.